Hey guys, welcome back to another video. Let's solve a few basic problems based on the formulas we have just learned. So I've made a few questions based on the basic formulas. So let's start off with question 1. A ball makes 160 revolutions per second. What is the angular speed rad per second? In circular motion, you're supposed to always keep your answer for angular speed in radians per second. So yeah, a ball makes 160 revolutions per second. 1 second is 160 revolutions. That means it's moving 360 degrees or 2 pi. In 1 second, it's moving 2 pi or the entire circle for 160 revolutions. Meaning it's going around the circle or going around 2 pi rad for 160 revolutions. So 2 pi times 160, we get the total angle turned, which is going to be 320 pi. So per second, it's going around 320 pi rad. Therefore, what is the angular speed? The angular speed, or omega, is going to be 320 pi. Because every second, it's going around an angle of 320 pi. So if it's doing 160 revolutions, we are multiplying it with the total angle, the entire angle, or 360 degrees or 2 pi. We're always going to calculate in radians. So 160 times 2 pi, we're getting 320 pi rad per second. Okay. It's basically a unitary method. Second question. A car of mass 250 kg completes a circle in 50 seconds while having a speed of 25 meters per second. Find the angular speed. Okay, so for this, let's say a car is completing this circle and it's doing it in, the time period is 50 seconds. What does that mean? It's completing one revolution or one oscillation in 50 seconds. And the mass of the car is 250 kgs. We know the mass, which is 250 kg. Now, what are we trying to figure out? The angular speed, which is very easy. If you remember the formula, omega, you can write it as, if you know the time period, 2 pi by t. This is one formula, and the other is del theta by del t, change in angle by change in time. Therefore, we know 2 pi by 50 seconds, 50. Therefore, omega is going to be 1 by 25 pi rad per second. Rad per second. Pi by 25 rad per second. Okay, this is the angular speed. Next, let's figure out the radius. For the radius, how many formulas do we know? We also have the speed, which is v is equals to 25 meters per second. Okay, so for velocity, there is one formula, which is v is equals to r omega. I've already shown the derivation for this. So v is equals to r omega. You know the tangential velocity. If they mention the car is moving at a speed of 25 meters per second, this is the value or the magnitude for tangential velocity. So 25 meters per second is equals to radius we don't know. We are trying to figure out the radius. And omega we know, which is pi by 25 rad. Pi by 25 rad per second. Okay, so from this you will get 25 squared, which is going to give you 625 by pi R is going to be 625 by pi meters. Which is 198 approximately. 199 meters. Okay, so this is the radius. Now, for 3, you need to find out the centripetal force. There are a few formulas to figure it out. One would be, let's say, F is equals to mv squared by r, or you could do F is equals to m r into omega squared, mr omega squared. You can use either of these. I'm going to use this formula. So let's say the mass is already given, 250 times velocity. You know the tangential velocity, which is 25 meters per second. So 25 squared by the radius. What is the radius? We just figured it out, 199. So if you calculate for this, it's going to be 250 times 25 squared by 199 is going to give you 785.175. 785 newtons. Now, if I do the same on this side, it's going to be 250 times 199 times, omega, which is it's going to be pi by 25 whole square. So let's do 250 times 199 times pi by 25 whole square. It's going to give you the same 785.62 newtons. So it's approximately the same value. If it's slightly different, it's going to be because we have taken the approximate values. So that can result in slightly deviated results. Okay, question 3. An object of mass 60 gram. What is the mass? Mass of 60 gram is going to be 0.06 kg. Is placed on a rough rotating disc. Okay, so an object is placed on a disc which is rotating. Okay, so the radius of the disc is 50 centimeter. So radius is 50 means 0.5 meters. So the distance between the center and the disc is going to be 0.5 meters. The disc provides with a friction of 0.3 newtons. What is the maximum angular speed possible without the object falling off? What does this mean? So the rough surface of the disc is providing the object with a friction force. Now, you know that friction force contributes to the centripetal acceleration or centripetal force. Therefore, we can say the centripetal force Fc is equals to Fr, which is the friction force. How do we know this? I've already showed in an example, in a previous example where, let's go back to that example. For this example, I've already shown that for a car traveling in this circular track, there is one main force acting towards the center, which is friction. This friction acts towards the center since the tires are rotating outwards. Let's say at this angle, which is why there is a friction force opposite to that direction, which acts inwards towards the center. So if the friction force is acting towards the center, that contributes to the resultant centripetal force. Therefore, we know that the friction is causing the object to remain on the disc. The friction force is the only force causing the object to remain on the disc. Without the friction, the object would have slided off. Therefore, we know it's due to the friction that the object can remain on the disk. They've mentioned what is the maximum angular speed, meaning if, let's say, the friction for this case is 0.3 newtons. If it is 0.3 newtons, the object can only stay on top of the rotating disk up till a certain angular speed x rad per second. We're going to figure that out. We're going to figure what the value of angular speed is. But just to clear out the concept, for let's say 0.3 newtons of friction, it can only tolerate an angular speed of x rad per second. If the friction was greater, let's say 0.4 newtons, it could experience a greater or tolerate a greater angular speed of, let's say, x plus 2 rad per second. Why? Because the friction force would then be able to, let's say, if F is equals to Fc equals to mv square by r, or let's make it easier, mr omega square. So for this, if the angular speed increases and friction stays the same, then friction will be less than centripetal force. So, to equal the greater angular speed, you need a greater friction force. If, let's say, you increase the angular speed to x plus 2 rad per second, it would no longer be able to tolerate that speed, which is why it would slide off. Therefore, if we calculate for this example, we know that the maximum angular speed is going to relate to the maximum friction available on the surface. So we know the centripetal force is given by the friction force. So Fr is going to be m into r into omega square. The friction is 0.3. We know the mass, which is 0.06. We know the radius, which is 0.5. We're going to figure out the omega. So the value of omega comes out to be root 10 rad per second. Therefore, this is the maximum angular velocity or angular speed that the object can tolerate. What happens if the angular speed increases? Let's find that out. So let's say the centripetal force is given by m into r into omega squared. If mass stays the same, which is 0.06 times radius stays the same, which is 0.5, and if you increase the value of omega, which is the angular speed, what happens? From root 10, let's say you go to root 12, it's going to give you a greater centripetal force, 0.06 times 0.5 times root 12. So it's giving you sorry, I forgot to square it. Right. So it's giving you a value of 0.06 times 0.5 times 12, which is 0.36. 0.36 is the value of centripetal force, the new centripetal force. Now you know that the friction is only 0.3 newtons. So these values are not the same. The centripetal force is greater than the friction, which is why at this angular speed, at this new angular speed, this object would slide off. Because it won't be able to counteract this new centripetal force, which is greater than the friction. The friction won't be able to provide this much of centripetal force. Therefore, they've mentioned, or I've mentioned, maximum angular speed. Because for this friction, this is root 10 is the maximum angular speed possible. If you increase the angular speed greater than root 10, the object falls off.